Friends, welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, where we are working on the daily LeetCode Challenge problem statement. Let us take a look at today's problem statement. The area says find the largest area of square inside two rectangles. So there exist n rectangles in 2D plane with edges parallel to x and y axis. You are given with two 2D integer arrays bottom left and top right, where coordinates are given, representing the bottom left and top right coordinates. We have to find the maximum area of a square that can fit inside the intersecting region of at least two rectangles. Return 0 if such a square does not exist. So we have been given with coordinates of starting and ending point of each rectangle, and we have to basically find the maximum possible area of a square that overlaps between two rectangles. So if you carefully observe the red and blue and this green, these are all three rectangles, and we have to basically figure out or determine the overlapping area of a square in all of the regions. Any two of the rectangle, not all, we have to only focus on any two rectangles. So if you clearly observe, it mentions about finding the maximum area of square. So max in intersecting in at least two rectangles, right? So what we can do, we can simply start iterating on all the possible combinations of rectangle. We are following the greedy approach here. We just need to basically use basic simple geometry technique to find the maximum width and maximum height that is overlapping between any two rectangles, and we have to simply return the square. We have to be, since we want to return the area of a square, we have to determine the minimum of the max width and the max height. That's it. So this problem statement reduces to simple implementation problem. First, we fetch out the total number of rectangles. Then we start iterating on these rectangles where max height is initially assigned to 0. So answer may be large. So we are declaring it as long answer. So whatever the max height that we will get, we will simply return, multiply it by its own and return the answer. Now, since we want to try all possible combinations of rectangles, we want to check g starting from I, g less than n, g plus plus, right? Now here we need to find the width and height. So in order to find the width, if you carefully observe, we have to apply the simple geometry technique to basically figure out what is the width that is overlapping uh, in between these two rectangles. Similarly, we have to find the overlapping height between these two rectangles. And in order to calculate that, we will use minimum of the top right of ith first columns x coordinate minus top coordinate top right of jth of 0. Similarly, we have to find the maximum of bottom left of I 0, bottom left of G 0. Okay, so this will give me the width, and I also need to, for height, similarly minimum of top right of I1, top right of I1. top rate of jth, sorry, yeah, maximum of, now we have to use for bottom left. Only change is I1 and G1. Okay, yeah. So this is where we get width and height. Now there might be possibility of width going into negative, right? So in that case, that are not overlapping. We simply add a condition of width greater than 0 and height is greater than 0. Then only we will update our max side. Max side comma. We'll type this to minimum of width and height. Why we are taking minimum here again? Because we want to return the square. In order to obtain the square, we have to choose the minimum side. Okay, and that's it. Let us try to run this. Okay, line 13, minimum of height of I1, top right of J1 minus bottom left of I1 and bottom left of J1. Was is missing here. Okay, my bad. Yeah, all the sample are passing. This fourth one is not passing because we are initially assigning to max side into 0 into 0. Okay, initially max side is assigned to 0. We are starting from j equals I0 to n, I plus plus j I plus 1 to j less than n, j plus plus. For where we are figuring out top right of I0, comma top right of J0 minus maximum of bottom left I0, bottom left J0, height is top right of I1, I1, yeah, it should be J1. Yeah. I guess all the sample test cases are passing. Let's quickly submit and check for the hidden test cases. And yes, we are successfully able to complete the problem statement. So if you ask me what are the learnings from today's problem statement, it's basically um, it's application of 3D logic and implementation based. So this will need some practice around or knowledge around the geometry because we are given coordinates and we have to find the overlapping width and height, right? So that's the learning from this problem statement. Apart from that, if we talk about time and space complexity, so we are using two loops, so goes to O of n square. Apart from that, uh, we are not using any external space, so space becomes O of 1. This n square is work, solution should work because if you carefully see in the constraints, we have n going to 10 power 3 only. So max in max, it can go to 10 power 6, which is fine and accepted. I hope the problem statement logic and the code is clear to you. If you have any questions or queries, please do let me know in the comments. If you are new to channel, please consider subscribing. Thank you for watching. Bye.